Okay, this is it. This is then the second lecture in linear algebra, and I've put below my main topics for today. That, I put right there a system of equations that's going to be our example to work with. But what are we going to do with it? We're going to solve it. And the method of solution will not be determinants. Determinants are something that will come later. The method we'll use is called elimination. And it's the way every software package solves equations. And so, and elimination, well, if it succeeds, it gets the answer. And normally it does succeed. If the matrix A that's coming into that system is a good matrix, and I think this one is, then elimination will work. We'll get the answer in an efficient way. But why don't we, as long as we're sort of seeing how elimination works, it's always good to ask, how could it fail? So at the same time, we'll see how elimination decides whether the matrix is a good one or has problems. Then, to complete the answer, there's an obvious step of back substitution. In fact, the idea of elimination is, you would have thought of it, right? I mean, Gauss thought of it before we did, but only because he was born earlier. It's a natural idea. And died earlier, too. Okay, so, but then, and you've seen the idea. But now, the part that I want to show you is elimination expressed in matrix language, because the whole course, all the key ideas get expressed as matrix operations, not as words. And one of the operations, of course, that we'll meet is how do we multiply matrices and why. Okay, so there's a system of equations. 3 equations in 3 unknowns. And there's the matrix, the 3 by 3 matrix. So this is the system AX equal B, you could say. This is our system to solve. AX equal, and the right-hand side is that vector 2, 12, 2. Okay. Now, when I describe elimination, it gets to be a pain to keep writing the equal signs and the pluses and so on. It's that matrix that totally matters. Everything is in that matrix, but behind it is those equations. So what does elimination do? What's the first step of elimination? We accept the first equation, it's okay. I'm going to multiply that equation by the right number, the right multiplier, and I'm going to subtract it from the second equation. With what purpose? So what that will decide what the multiplier should be. Our purpose is to knock out the x part of equation 2. So our purpose is to eliminate x. So what do I multiply? And again, I'll do it with this matrix because I can do it short. What's the multiplier here? What do I multiply equation 1 and subtract? Notice I'm saying that word subtract. I'd like to stick to that convention. I'll do a subtraction. So first of all, this is the key number, right, that I'm starting with. And that's called the pivot. I'll put a box around it and write its name down. That's the first pivot. The first pivot. Okay, so I'm going to use, that's sort of like the key number in that equation. And now what's the multiplier? So I'm going to, my first row won't change, but that's the pivot row. But I'm going to use it. And now finally, let me ask you what the multiplier is. Yes? 3. 3 times that first equation will knock out that 3. Okay, so what will it leave? So the multiplier is 3. 3 times that will make that 0. That was our purpose. 3 2s away from the 8 will leave a 2. and 3 ones away from 1 will leave a minus 2. And this guy didn't change. Okay. Now the next step, so that step of, this is forward elimination, and that step's completed. Oh, well, you could say, wait a minute, what about the right-hand side? Shall I carry, the right-hand side is like, gets carried along. Actually, MATLAB finishes up with the left side before, and then just goes back to do the right side. Maybe I'll be MATLAB for a moment and do that. Okay, so I just, like, I'm leaving a room for a column of B, the right-hand side, but I'll fill it in later. Okay, now the next step of elimination is what? Well, strictly speaking, I cleaned up, this position that I cleaned up was like the 2, 1 position, row 2, column 1. So I got a 0 in the 2, 1 position. I'll use 2, 1 as the index of that step. The next step should be to finish the column and get a 0 in that position. So the next step is really the 3, 1 step, row 3, column 1. But of course, I already have 0. Okay, so the multiplier is 0. I take 0 of this equation away from this one, and I'm all set. So I won't repeat that, but there was a step there which MATLAB would have to look. It would look at this number and do that step unless you told it in advance that it was 0. Okay, now what? Now we can see the second pivot, which is what? The second pivot, see, we've eliminated, x is now gone from this equation, right? We're down to 2 equations in y and z. And so now I just do it again. Like, everything's recursive at this. This is such a basic algorithm, and you've seen it. But carry me through one last step. So this is still the first pivot. Now the second pivot is this guy who has appeared there. And what's the multiplier, the appropriate multiplier now? And what's my purpose? Is to clean up is to wipe out the 3, 2 position, right? This was the 2, 1 step. And now I'm going to take the 3, 2 step. So this all stays the same. 1, 2, 1, 0, 2, minus 1. And the pivots are there. Now I'm using this pivot. So what's the multiplier? 2. 2 times this equation, this row, gets subtracted from this row and makes that a 0. So it's 0, 0, and is it a 5? Yeah, I guess it's a 5. Is that right? Because I have a 1 there, and I'm subtracting twice this, so I think it sits a 5 there. There's the third pivot. So let me put a box around all 3 pivots. Is there a, I think that, oh, did I just invent a -1? I'm sorry that the tape can't correct that as easily as I can. Okay, is that, thank you very much. You get an A in the course now. Is that correct? Is it correct now? Okay. So the 3 pivots are there. I know right away a lot about this matrix. This elimination step from A, this matrix I'm going to call U. U for upper triangular. So the whole purpose of elimination was to get from A to U. And literally, that's the most common calculation in scientific computing. And people think of, how could I do that faster? Because it's a major, major thing. But we're doing it the straightforward way. We found 3 pivots. And by the way, I didn't say this. Pivots can't be 0. I don't accept 0 as